Hello, my name is Antonio Pinheiro Braga, and along with my colleagues from Stockholm University, Johanna Urish and Karan Dudeja, I'll be presenting To Merge or Not to Merge, the possibilities of mixed reality in theater production. This research is motivated by the technological advancements of mixed reality along with its application in the performing arts. In addition to this, the research is also motivated by the difficulty theater actors face when transitioning from the rehearsal room to the stage. This is due to the large gap between the rehearsal space and the final set in terms of spatial fidelity of the performance. Therefore, our research question is, how can mixed reality facilitate spatial awareness and movement of actors during theater rehearsals? For the methodology, we implemented a research through design approach. The research was initiated with interviews with experts from the field. The collected data was analyzed for thematic analysis. This provided a theoretical base for the prototypes that were developed, which were then used in the design workshop. Lastly, the output of the design workshop is analyzed in order to answer the research question. For the creation of these prototypes, we used the Unity game engine and the MetaQuest Pro and Quest 3 mixed reality headsets, as they allow the user to interact with virtual objects while at the same time be able to see their surroundings thanks to their color pass-through functionality. Based on the feedback from the interviews with the experts in this area, we were able to come up with 3 different prototypes. The first prototype was meant to serve as a way to visualize movement and facilitate tense choreography sessions. In order to do this, we chose to create a 3D drawing tool, as this not only would pinpoint with precision the position of the user's hands, which allows them to trace back and review their steps, it also serves as a multi-purpose tool due to its nature, allowing, for example, to draw temporary markers and boundaries on the set or any other visual aids. The second prototype, called Blockout, is meant to specifically help with the example previously given. Should the users want to place an object on set that is meant to represent a physical prop, they can select 4 distinct points on the ground and then set the height of the virtual object. By including the height and establish a third visual dimension, we can replace temporary markers from a set that are usually done with a tape on the ground. This prototype also includes an optional precision grid that allows the users to calculate and draw the object's desired length and width without needing to make a visual estimation of it. The third prototype takes a step beyond the second one, as it allows the user to include their very own 3D virtual models on the application and place them on the set. The prototype can differentiate floor from walls and ceiling, and will only allow for objects from their respective categories to be placed in the correct space. For example, a chair can only be placed on the floor. In order to achieve this, we use MetaScene API that is provided inside the Oculus SDK. This prototype can potentially allow for professionals to try out different props before choosing to create a physical one, reducing the cost that this incurs or even erase them completely should a creative performance be meant to be experienced in mixed reality. Another benefit of this prototype is that it can allow for the professionals to use complex visual effects and simulate something that might not be allowed due to safety concerns, such as pyrotechnics. The prototypes were explored by the participants in a design workshop in order to inspire them for their own ideas of mixed reality application in theater rehearsal. The participants visualized their ideas using the provided material. The design material was then presented and discussed in the group. From the output of the workshop, we conclude that the pass-through capabilities of mixed reality can aid movement by allowing the actor to perceive their own body. In addition to this, using low-fidelity objects for mapping out the set is seen as more useful than using high-fidelity props, as it allows the actors to use their imagination more, thus facilitating the creativity and immersion required for acting. In conclusion, mixed reality can facilitate spatial awareness and movement in theater rehearsal by augmenting the physical space and actors' movements to provide an abstract visual representation of the final performance, while still taking the physical space into consideration. This allows the actors to perceive the space they are working with and assess their movements within that space as well as adapt to them accordingly, thus easing the transition from rehearsal room to final stage. In addition, the visual representations have potential as a tool for achieving common ground within the production team. However, future study on collaboration in mixed reality is needed to investigate this.